So this one, if we divide both sides by xy, you're going to get y squared over xy minus x squared over xy. Everything looks fine. dy dx equal to, now we can cancel some things. You're going to get y over x minus x over y. So dy dx equals u minus 1 over u, and dy dx can be substituted with u plus x du dx. Now, you want good news or bad news? The bad news is these u's are not going to cancel out every time. I've had examples where they have. Just don't expect them always to cancel. That's just kind of freak luck. But these do, and so now the homogeneous form, x du dx equal negative 1 over u, you can put the u's together, and you get u du and negative dx over x. Now we'll do the integral both sides. This is the proving step. You've proved homogeneous once you get to this step just before. Wow, you are stubborn. There we go. Proved homogeneous. All right, so now we're going to work this out. This is just going to be u squared over 2, negative natural log of x plus c. Now you bring in your point, 1, 0, and now we have to find c. So xy. So now you might want to change your u here, because u is y squared over, or u over x, so squared will be y squared over x squared, and what was that, over 2 times it was all over 2, u squared over 2. So now we put those in, and y is 0, so this will just be 0 is equal to negative natural log of 1 plus c. What's c equal to? It's just 0, isn't it? I like it when c is 0. Makes me so happy. So now we're going to get y squared over 2x squared equals negative ln of x plus 0. So then I'm just going to get y squared is equal to negative 2x squared ln of x. And it will be y is equal to plus or minus square root negative 2x squared ln of x. Now, I don't understand this, because I don't think this could be an actual answer. Yeah. Yeah, that's true. That's true. If x is less than e, then it's between, yeah, then it could be. But x can't be negative, right? X can't be negative, or the natural log won't work. So, and you can't take the square root. I don't think it's going to work.
You mean less than 1?
Oh, no. That's right. That's right. If it's between 0 and e, then this will be negative. You're right. There are some values that'll work. Wow, that's tricky. So there's your answer for that one. All right, so with this last one on this list, it says find the particular solution for dy. Well, we can substitute u plus x du dx And that's going to be 3y squared over 2xy. So 3y squared over 2xy plus x squared over 2xy. Yeah, those constants are going to be trouble, aren't they? U plus x du dx, we're going to let u equal to y over x again. Always do that substitution unless it tells you otherwise. Because of this dy dx, that's a logical one to do. So one of these y's will cancel, one of these x's will cancel. So you'll get 3/2 u plus 1 over 2u. What's going to happen when I subtract u from both sides? It's not nice, is it? X du dx is going to be equal to 1/2 u plus 1 over 1/2 1 over u. So what some people are going to do is they're going to go x du dx is equal to 1/2 times u plus 1 over u. Are you okay with that? Now what? Let's get a common denominator. So you have x times du dx equal to 1/2 u squared plus 1 over u. If we put the u's on one side, you're going to get u over u squared plus 1 du. And then on the other side, we're going to get, what is that? dx over 2x. Is that right? Dx over 2x. Now when you integrate, this is where you might have to do a little bit of thinking. What integration method are we going to use for this? Is it arctangent? No, not arctan. It's going to be, yeah, it's a u sub. U is, maybe w is u squared plus 1, and dw is 2u du, which you have the u du, you just need the 2.
We already have it.
You do, kind of, don't you? I'm going to, if you don't mind, I'm going to move this thing over to here. Is that okay? I should have done that before. So now, with this, I have it. Now this is just going to be integral of dw over w, natural log of x, plus c. And what's the antiderivative of dw over dw? The natural log of w, which was u squared plus 1, equal to the natural log of x plus c. Did they give us a point on this one? Oh, 1, 2. See what you can do with that. So don't forget, this is y over x. So this is going to be the natural log of 2 over 1. 2 squared is 4 plus 1 equals the natural log of 1 plus c. Well, c plus 0 is equal to the natural log of 5. So c is the natural log of 5. So here goes. Natural log of y squared over x squared plus 1 is equal to the natural log of x plus the natural log of 5. Now we can combine these into one log. Remember the property? ln of what? Yeah, and I'm going to write that. ln of y squared over x squared plus 1 equals the natural log of 5x. Yep. Okay, now what? Careful. Careful, careful, careful. You could. You don't have to, though. Can't you just say y squared over x squared plus 1 equals 5x? Yeah. If there was anything out here, no, but so then I'm going to get y squared over x squared equals 5x minus 1. I get y squared is equal to x squared times 5x minus 1. Y squared equals 5x cubed minus x squared. And I don't know what they had for an answer. Yeah, I agree. I agree. But that, unless they tell you otherwise, that's fine to leave it that way.